Today we are here to talk about Chapter 9 for Chem 130, Chemistry 130 class. This chapter is over acids and bases. So what is an acid? An acid is something that produces H plus ions in water. That's the most important thing to remember from this slide. They also taste sour, act corrosive, and they can turn blue litmus paper red. But the most important thing is they produce H plus ions in water. We call those hydronium ions. What about bases? The important thing on this slide again is what bases produce in water, and they produce hydroxide ions, OH minus ions in water. If you have a basic solution, there's going to be OH minus floating around in the water. They also taste bitter, chalky, they can feel soapy, kind of slippery. If you've ever touched bleach, bleach feels slippery, and they can turn red litmus paper blue. But again, the important thing is they produce hydroxide ions in the water, OH minus ions, the way acids make H plus ions, and those are floating around in the water. So Arrhenius came up with the definition of acids and bases. Let's look at the Arrhenius definitions. He said that acids produce H plus in aqueous solutions. The example here is a very common acid, hydrochloric acid. So we have our hydrochloric acid. It's dissolved in water. That's what the AQ means, dissolved in water. And the arrow shows us that the H and the Cl break apart into H plus and Cl minus ions, aqueous ions, and they float around in the water. Now this is an acid because of that H plus. The H plus is why this is an acid. It produced H plus ions. That is what makes it an acid. Let's look at bases. Bases produce OH minus in aqueous solutions. That is the Arrhenius definition of a base. Sodium hydroxide is a very common base. Again, when we put sodium hydroxide into water, breaks apart, as the arrow shows, into Na plus ions and OH minus ions. It's the OH minus ions that make it basic. OH minus ions floating around make something a base, and that is why sodium hydroxide will produce a basic solution. Again, these are Arrhenius definitions. Acids make H plus, bases make OH minus. Arrhenius said this. A neutralization reaction, we've already covered those. In general, an acid plus base makes a salt plus water. Now what is a salt? Well, it's a metal and a nonmetal that come together and either bond or stay dissociated in water. We call these salts. It's just an ionic compound, a metal of the nonmetal. For example, let's take our hydrochloric acid that we just looked at and our sodium hydroxide that we just looked at and put them together. What happens is the H plus that's floating around from the acid and the OH minus that's floating around from the base find each other, bond together, and HOH is, of course, water. So we get liquid water. Then you still have an Na plus floating around and a Cl minus floating around. So that is NaCl, and it stays aqueous actually because it's soluble. The Na plus and the Cl minus don't bond together because NaCl is soluble. All sodium compounds are soluble, solubility rule number 1. And so the NaCl stays aqueous, dissolved as ions in the water. That's why the NaCl gets an aqueous after it. So again, that's a neutralization reaction. Acid plus base makes salt plus water. And a salt is just a metal and a nonmetal, an ionic compound. Now let's look at the Bronsted-Lowry definition of acid bases. These are a little bit different. Bronsted and Lowry said that an acid is a proton or H plus donor. So it's something that loses H plus. Whereas a base is a proton, H plus acceptor. So a base is going to gain the H plus, the acid loses the H plus. Why do we say that's a proton? Well, if we look at hydrogen in the table, it only has one proton to begin with and one electron. So if it loses that electron to make it H plus, then all that's left is a proton. So the H plus ion is actually just a proton. And that's why it's so reactive, so dangerous. So let's look at the reaction on the screen. We have again our hydrochloric acid, HCl. This time we have NH3, aqueous. And look at the products. NH4 plus, aqueous, dissolved in water, plus Cl minus aqueous dissolved in water. Let's look at before to after. We started out with an HCl, but on this side we have just the Cl by itself. What happened to the HCl? It lost the H plus to become Cl minus. Look at the NH3. It became NH4. 3 to 4 H's. You're right, it gained the H plus. So NH3 gained an H, and HCl lost its H. Thus, we have a Bronsted-Lowry acid-base reaction. There we go. We can see the picture below. We have the red atom. That's our Cl with the little gold H on it. If you look on the product side, the Cl's by itself. It lost that gold H plus atom. If you look at NH3, N is blue with 3 gold H's around it, NH3, and it becomes NH4 plus. It gained that H. So the H went from the HCl to the NH3, making NH4 plus and Cl minus. Again, losing and accepting an H is a Bronsted-Lowry acid-base reaction. All right, now let's look at some strong acids and bases. Strong acids ionize completely, like practically 100% in water, 95% or more. We have 3 strong acids we want you to learn. HCl is hydrochloric acid, HNO3 is nitric acid, and H2SO4 is sulfuric acid. These are all strong acids. So we're going to use HCl as our example. It has a single arrow pointing towards the products, and it breaks apart completely into H pluses and Cl minuses. All of it ionizes. Ionize means turn to ions. So it all ionizes. So the HCl completely ionizes in the water. H plus and Cl minus are our products. Single arrow going over. What about a strong base? Well, it's the same thing. It's going to break apart 100% in water to form ions. So it's going to dissociate completely. That's another word we use for breaking apart into ions. There are 2 strong bases we want you to know. KOH, potassium hydroxide, and NaOH, sodium hydroxide. So those 2 are our strong bases, and they are going to break apart 100% in water, as shown by the NaOH. The NaOH aqueous breaking apart with a single arrow again, going to Na plus and OH minus ions. So all the NaOH breaks apart into Na plus and the OH minus, which is why it's a base, and it breaks apart completely. So those are strong acids and bases breaking apart in solution in the water completely into ions. Here's a picture of the strong acid and the strong base. So we can see in the picture that HCl is completely composed of ions. H plus Cl minus, H plus Cl minus, H plus Cl minus. All ions. That is strong. All ions are strong. Look at the NaOH. We got Na plus, OH minus, Na plus, OH minus, Na plus, OH minus. All ions. Again, all ions is strong. Strong acid or base when we have all ions. So our strong acids and bases. Our acids were hydrochloric acid, nitric acid, sulfuric acid. Our bases were sodium hydroxide and potassium hydroxide. Now what did strong mean again? What does that mean? You're correct if you were thinking breaks apart in water 100%, ionizes 100%. What ions are produced in water for an acid? What do we have to have in solution for it to be acidic? I hope you said H plus. What about basic? What ion has to be in water in order to be basic? I hope you said OH minus. Alright, so if we have strong acids and bases, we have weak ones as well. So let's think about what weak means. Well, weak acids ionize very little, just maybe 1 to 5% in water. So most of it stays bonded together. Only a few break apart. Most of them stay together. We have 4 weak acids for you to memorize. I know that's a lot. The 4 acids are hydrofluoric acid, HF, carbonic acid, H2CO3, acetic acid, HC2H3O2, also known as vinegar, and then H3PO4 phosphoric acid found in soda. So those are our 4 weak acids. They do not break apart 100%. They only break apart a little bit. Let's look at the example of the acetic acid in water. We can see now a double arrow. That's because the reaction does not go all the way to the products. So we have a double arrow because most of it stays over on the reactant side. So we have HC2H3O2, like 95 to 99% of it stays bonded together. Only 1 to 5% goes to products and makes the H plus the C2H3O2 minus, the acetate ion. So most do not break apart. Only maybe 1 to 5% of the acid is ionized. Okay, most of it stays on the reactant side bonded together. Weak bases also dissociate very little, just a little bit, 1 to 5%. So just a few ions are formed. The weak base we want you to learn is magnesium hydroxide. Magnesium hydroxide is very much insoluble. Only a little bit will dissolve in the water. So we have the equation MgOH2 solid with the double arrow again. Double arrow meaning it doesn't go all the way to the products. Most of it stays over on the reactant side. And we get Mg plus 2 aqueous plus 2 OH minus aqueous. Notice there's 2 hydroxides in magnesium hydroxide. So don't forget the 2 in front of the OH minus. Let's look at the pictures now. The first picture of HF is one of our weak acids. Notice in the picture, most of it stayed together. HF, 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 HF. Only one of them came apart, H plus, F minus. That's why it's weak. Only a little bit came apart. Most of it stayed together. Let's look at the Mg2 plus OH minus picture. We got Mg2 plus and 2 OH minuses. And then most of it stayed at the bottom. That little squiggly line down at the bottom means solid. Most of it's down there, like 99% of it is MgOH2 down at the bottom in the solid state. Only a little bit broke apart and is up in the solution, represented by the Mg2 plus and the 2 OH minus ions. So again, weak means just a little bit dissociates, just a little bit. So our weak acids and bases. The weak acids were hydrofluoric acid, carbonic acid, phosphoric acid, acetic acid. The weak base was magnesium hydroxide. What does weak mean again? All right, you're correct if you said just a little bit breaks apart. Only 1 to 5% breaks apart. Most of it stays together. Very different from the strong acids and bases. So here's a picture of 4 beakers. We have some atoms, some ions in them. Let's look at those, A, B, C, and D. Which of these 4, if any, is a strong acid? You're correct if you said A. A is all ions. All broken apart means strong. Okay, when it's all ions, it is strong. So A is a strong acid. It's an acid because it has H plus in it. You have to have H plus ions to be an acid. Beaker A has a lot of H plus, A minuses. It is strong. It's a strong acid. All right, which of these, if any, could be a weak acid? If you said B and C, you're correct. It is both of them. Both B and C could represent a weak acid because we have HA bonded together and then we just have 1 or 2 apart. Most of it is bonded together. HA, 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 HA. Only 1 or 2 is apart, H plus, A minus. So again, H plus makes it an acid. Okay, H plus makes it an acid. The fact that most of it is together, HA, makes it weak. Okay. Which is a strong base, if any? I hope you said none of them. What do you have to have in solution to have a base? OH minus. Do we have any OH minus? No, there's no OH minus in any of those pictures. So, there is not a strong base. So what is D? Does it have H plus in it? No. Does it have OH minus in it? No. So it's not acidic or basic. Looks to me like it's a neutral solution. Okay. All right. We're going to continue chapter 9 in a different video. That way you can take a little break. Thank you.